All right, welcome back, guys. Looking at a test review for Unit 4, Congruent Triangle Test. We got some proofs on here. We got a lot of things going on. I'm going to work through these, do the best that we can. Number one is a proof, and we've done a proof very similar to this one in the past. I have all the answers already filled out here. If you want to take a look at those, boom, there they are, just to check your work. But if you need an explanation, I'm going to kind of do my work out over here. So what do we got? We got given BF is congruent to ON. First step, every proof is you start marking up the given information. They told us those two sides are equal, and here they tell us that those two sides are parallel. So you mark up the given information always. If there's something to write about, you write about it. But we're going to write a proof, and I'm going to just kind of freehand it over here. So what are some things that we know? Well, parallel lines do some stuff for us. They give us equal angles. And if we follow the parallel lines, like whoop, we would know like angles 1 and 2 have to be the same size. Could we also do the same thing going on the other side of the parallel line? Yes. So I know because of the parallel lines that these two angles are going to be equal. I also know that these two angles are going to be equal. Those use the parallel lines. A big mistake that people do is that they would go like this direction. Do these angles use the parallel lines? No, they don't. So we can't say that those angles are equal, so please be very careful. So I'm kind of marking those up. I'm not going to write about them just yet, but I'm going to be thinking about them. Hey, these are things that I know. Now, there is more than one way to do this proof. And if it was on the test, you could do it either way, but they gave us specific guidelines because this is not a free response proof. So I'm going to kind of walk through the way that you could do it if it was free response. You could build these two red triangles. Don't you already have two angles and an included side? Aren't the red triangles congruent? Yes, they are. So just so you know, there's a path to solving this proof if you do that. But one thing I want you to be on the lookout for is, what are you actually trying to prove? You're trying to prove that angle BOR, that's this angle, is congruent to NFR, this angle. And so I know it's tough, guys, but I'm looking at this and I'm like, man, are there any triangles that use the pieces I have, right, all the red parts, but also use those two blue angles? Because if I can get it all in one big shot, that would be awesome. And if I trace that side and this angle, doesn't this big triangle have that angle at the top that I want? And if I do the same situation down here, don't I have the other angle that I want? So this is a huge shortcut. And if you see this, you're going to do a much better job, or not a much better job, but you're going to do it a lot faster. So what do we actually need to write in our proof? Well, I need angles 1 and 2, so I'm going to write that in here real quick. I'm going to call them 1 and 2, and how do we know? That's the alternate interior angle theorem, right? Those are because of the parallel lines. They gave us this straight up, so I don't have to write about that. And if we draw the triangle that we're working on, like this is the blue triangle, we have this side, we have this angle. What else do we have? It can be hard to tell sometimes. Sometimes it helps to write the names. I'm working on triangle FBO and triangle ONF. Well, don't they both use OF? Right? Do you see in the picture how OF is a shared side? Yes. So I'm going to say OF is congruent to OF, and that is the reflexive property. They both use that side, and that's the third piece we need, and now we have an SAS situation. So I can now say triangle BFO is congruent to triangle NOF, side, angle, side. And aren't these the corresponding angles for those? Yes, I will say, some of you guys might be a little concerned. It's called BOR. Isn't BOR the exact same angle as BOF? They're the same corner, guys. So you could name it either way. It doesn't matter. But either way, it is this O from this triangle is congruent to the F on this triangle. So we now have our answer. We can now say angle BOR. Since they said R, I'm going to say R is congruent to angle NFR. And those are the corresponding parts of congruent triangles. Therefore, they're congruent. Ooh, tough little job there. I know you guys can do these, though. All right, moving on. This is a test in do you know how to use congruency statements, or are you going to let the picture mess you up? So they gave us KR, right? You see that? You see KR? I know you do. I know you do. What does KR go with? It goes with RA. KR goes with RA. Did you hear that? Can I hear a yes? Let's go. If you looked at the picture, a lot of people are going to say that these two are equal, KR and RE, but they did not draw the triangles in corresponding order. For this triangle, they went KOR, that's top, left, right. For this triangle, they went REA, that's top, right, left. That is not the same order. So you can't go by the picture. They're not going to always draw it correctly for you. But we know that KR is equal to RA from the name. So it's these two that are equal. And that's already enough to set up an equation. We know that x squared plus 7x has to equal 44. We know it from the name. You got to go by the name. So this is a quadratic equation. We need it to be ax squared plus bx plus c equals 0. We need it something x squared plus something x plus c. So I want to make this side 0. So x squared plus 7x minus 44 equals 0. And then you ask yourself, what factors of c add or subtract to equal b? Well, this one is a minus, so what factors of 44 subtract to equal 7? That's the question. Well, it's going to be 11 and 4. And because it's plus 7, I need plus 11 minus 4. Woo! So those are my factors. So x would equal negative 11 or positive 4. But wait, this is geometry. We got to test them out. And you need to test it out everywhere you see it. So if I go up here, if I plug in negative 11 squared plus 7 times negative 11, that's going to be okay. That's going to be 121 minus 77. That's an acceptable size. But what about here? 4 times negative 11 plus 5. That is going to be negative 44 plus 5. That's negative 39. That doesn't work. The negative 11 doesn't work on RE. It has to work everywhere. So then we plug in 4. Does 4 work everywhere? Let's try the first one. That would be 4 squared plus 7 times 4. That'd be 16 plus 28. That would be 28, 38, 44. That's an okay number. And then it's supposed to be 44, so we're in good shape there. The other situation, let's see, 4 times 4 plus 5, that is 16 plus 5, that's 21. That one checks out, that one checks out. I'm feeling real good. It says, what is the perimeter of the triangle? So what do we know? We know KR has to be 44, right? These are both 44, we know that. We know that EA is 30. They told us EA is 30. Well, what does EA go with? It goes with OR. So OR is 30. And then we just found out that RE, I can't see it, is 21. So RE is 21, which means KO is 21. So how do you get a perimeter? You add them up. 44 plus 21 plus 30. That is 44. That is 64, 65, 95. There's our answer. Woo! If you didn't use the name, you got stuck and you got lost. You got to go by the name. All right, what additional information would be needed to prove triangle ADC is congruent to CBA by the HL congruency method? So let's take a look. What do we know already? We got the right angle already, so we got the hypotenuse part, right? Oh, sorry, not the hypotenuse. We got the right angle, but we have a shared side that's a hypotenuse. So if I'm looking at this triangle, I have these two pieces of information, right? We've got the hypotenuse. Oh, this is actually the wrong answer. Yikes. I was just looking at that. I was like, we'll get the answer here in a second. So how do you do HL? We need a hypotenuse and we need one of the legs. It could be this leg. It could be this leg. So which one of our choices would give us a leg? Well, that's another angle. That's out. Those are parallel lines. That's out. Here are congruent lines. Let's see. If this AB was congruent to DC, do I have HL? Yes, I do. AB congruent to DC, HL. That's our answer. I know I just made it real messy down there. This is our answer. Boop. AB is congruent to DC. Sorry that I had the wrong one there. That's embarrassing. That's okay. All right, this is one of the tougher ones, and I had to switch it up. So I actually made the problem incorrectly when I first made it. Shouldn't affect you, but let's take a look. Triangle BIE, again, a congruency statement. One thing I'm going to do, I didn't do in the last one because the picture is more complex. There's like shared sides. There's lots going on here. Is I'm going to mark up the picture, at least the sides here, like because, well, actually I can mark the angles as well, but I'm going to mark the sides real quick. We know that BI goes with EI, right? Like we know that BI, they already used a 1 dash, I'm going to use a 2 dash. We know that BI has to be equal to EI. We know that BE has to be equal to EG. Well, look at EG. EG already has that 1 dash, right? So we know that BE is going to get a 1 dash because EG has a 1 dash. And then we know IE has to be equal to IG. So IE, we put a 2 dash on. Well, that means IG needs a 2 dash. That might have been kind of confusing, but like we know that about the sides right now. So there's some lot going on here. How about the angles that they gave us? Angle B is 50 degrees. Now think real hard. Angle B on this triangle would go with angle E on this triangle. And I'm going to highlight that triangle. Here's the second triangle because it has a lot of shared sides and stuff. Angle E within that triangle would be this corner. That corner would have to be 50. So B has to go with E. Then they tell us angle BIE. BIE would be this corner is 88 minus X. Well, that's basically vertex I, right? Like vertex I goes with vertex I. So inside the purple triangle, vertex I has to be the same size. And then EGI, vertex G. What does vertex G have to go with? Vertex E. But vertex G inside the purple triangle is 9x minus 22. Let's see if we can get that a little bit better. 9x minus 22. And what did G have to go with? This guy, E, 9x minus 22. So what do we know about the three angles? There's a few things we actually can tell, but the more obvious one that most people would see is that 88 minus x plus 9x minus 22 plus 50, those three angles have to add up to a full triangle, 180 degrees. So we have 9x minus x would be 8x. We have 88 minus 22 would be 66 plus 50 be 116. So 8x equals 64, x would equal 8. So that's actually the first answer there, x equals 8. Okay, well if I plug in 8, 88 minus 8 would be 80. 9 times 8 would be 72. Minus 22 would be 50. Which means if that one's 80, this one's 80. And if that one's 50, this one's 50. So look at all these things that we know. This is a tough question. If you don't fill out everything you know as you go, you would get stuck, no doubt. So what do we need? We need angle C down here. Woo, okay. How can we get angle C? Well, we know that this much is 50 plus 50. Isn't that 100? So what do all three of these have to add up to? Well, you said 180. You were right. Those three angles form a line. So that has to be 80. And do you notice that these two sides are equal? That means we're working in an isosceles triangle. That means that both of these corners would have to be 50. So angle C would have to come in at 50. Is E the midpoint? Remember we went back to our markings? Based off the name, isn't BE equal to EG, right? Look at the names. BE is equal to EG. We know that from the congruent triangle. So those both got a 1 dash. And then they marked this side with a 1 dash. So like if this was 10, then this would be 10 because they marked them equal. That was the original picture. And from our congruent triangles, if EG is 10, this would be 10. So you tell me, is E the midpoint of BC? Well, based off everything we know, that answer has to be yes. There were other ways we could have solved this, by the way, guys. If you had realized these two sides are equal, this triangle over here is also isosceles. So don't those two angles have to be equal? And they did come out equal. So there were multiple ways you could have approached this question, but it all starts with the congruency statement. Everything I did was based off which sides and angles had to be equal based off that congruency statement. And you've got to keep that in mind as you're working through problems. Triangle ABC is equilateral. Well, that's probably pretty important. That means every corner is 60. That means 3x minus 15 is equal to 60. There's the answers if you need them. So 3x equals 75. So what does x equal? 25. Got it. So we know that this angle is 60. We know that x is 25, right? But we need to get y. We'll look at this triangle in isolation. So we got another property here. Isn't this a remote plus a remote equals an e? So we know that 60 plus 10y plus 20 has to equal 55y minus 10. We know that r plus r has to equal e. And since we know that angle has to be 60, I plugged in 60 for that angle. So this is the equation we got to solve. So subtract the y over. This would be 45y. 60, 70, 80 minus 10 would be 70. Wait, 55 minus, let's make sure we got the right numbers. 10y plus 20. So that would be 80. Oh, plus 10. I was like, thought the answers were all whole numbers down there. I messed up. So subtract 10y, get 45y, add the 10. 80 plus 10 is 90. So y would equal 2. So how big is angle BED? They want actually that angle. Well, let's get the one next to it. That would be 110 minus 10. That would be 100. So if this angle is 100, the one next to it would have to be 80. Boom. Got it. Some good stuff there. But if you had to use your equilateral properties, they told you that right at the beginning. All right, this is another one that's really tough. You have to pay attention to the names. So we know that triangle YOU, I'm going to go top, left, right, is congruent to ROK. And then if I go top, left, right on the first one, I want to go top, left, right on the second one. Now here, the next sentence is an algebra sentence. It says RKO is 10 more than twice UYO. If you remember from Algebra 1, we're basing RKO on UYO. I'm going to call that my X. UYO, I'm going to call X. That means that these angles are both X. How do I do 10 more than twice X? Okay, well, 10 more than, if you remember from before, 10 more than means something plus 10. Well, what are we doing? We're doubling X. So it's 2X plus 10. They're saying that RKO is 2X plus 10. Angle RKO is 10 more than twice UYO. RKO is 10 more than 2 times X. So RKO down here is 2X plus 10. Okay, still too much. Is 2x plus 10. Now this next sentence, very, 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 very important. It says UYO is the vertex angle. Well, if UYO is the vertex angle, that means these two sides are equal. That means these two angles are equal. So same thing over here, because these triangles are congruent. So this is also 2x plus 10. So what we know is that 2x plus 10 plus 2x plus 10 plus x has to be 180. So that's 2, 4, that's 5x plus 20 has to equal 180. So 5x has to equal 160. So that would be 20 plus 12. X has to be 32. Type it in just in case I mess something up. Got it. All right, well, if x is 32, it says classify it by its angles. Let's go back and plug it in. This would be 32. This would be 64 plus 10 would be 74 and 74. Well, all of those angles are acute, making it an acute triangle. But you had to read carefully and do a really good job on that one to understand exactly what to do. All right, that's the last one on here. Let's go. We're going to do great work.